Hello guys. So today we are discussing closure property in database. Okay. So how can we find the closure of any key? Okay. And how can we find the candidate key and super key from relation and their functional dependency also. So this thing we will learn today. So closure. Okay. If I have one relation, like what can I say? I have one relation R and I have four attribute. Attribute means column are there, and I have like functional dependency also. A tends to B, C, and D. Next functional dependency, AB tends to CD. Next is ABC tends to D. Okay, and the next is C tends to AD, and then next is BD tends to AB. So, like we have this relation, and we have this five functional dependency, different. So, how can we find the like closure property from any relation or using this functionality? Okay. So, firstly, we will take the simple relation like ABCD again. Then I have a relation B tends to ACD and ACD tends to B. Okay. So what happened? That this I have two functional dependency. So this is the left side of any functional dependency, and it is the right side. Okay, same is that. So what is left side? We always find the closure property of left side attribute. So like I have said that I have to find closure property of B. So how can we find using this functional dependency? B tends to what we have? What we have B tends to ACD. So we will write ACD. But B itself is also come here. Okay. So B itself is also here. So what can we see now? That what can we see? That B includes all attribute of relation, all attribute of relation including. So the attribute means the attribute which is including all attribute of relation. It is called candidate key. Okay, it is called candidate key. The next what is in left side ACD. So we will find the closure property for ACD. Can we find or not? ACD means we have this relation. Okay, ACD tends to B. Second relation we have this. Okay, this one. ACD tends to B. So ACD tends to B. ACD itself is also come A, C, and D. And what is in the relation? ACD tends to B. So again, ACD is include all the attribute of relation ACD for attribute. Okay, so it is again our candidate key. Okay, so in this relation both are the B and ACD, both are our candidate key. So like this we will find. Now what happened? Again we see. What can we see? That if we can say that I have told you that CK. What is CK? It is SK, means super key. Okay, super key. Super key has super key also the collection of one or more attribute, and candidate key is also collection of one or more attribute. But it is minimal set of attribute. I have told you in previous video that C candidate key it has a minimal set of attribute. How it is minimal set of attribute? Like in the previous example, we have seen two candidate key B and ACD. So ACD has three attributes A, C, and D, and it is one attribute. So obviously, uh, whatever is super key, it will be a candidate key, and whatever is candidate key, it can be it can be considered as a primary key. Okay, but candidate key and super key has different states. Candidate key has a minimal set of attributes, so we can say it is a candidate key. It is also it is candidate key because it has a minimal attribute, and we can consider it as a super key because it has more attribute. Okay, and any candidate key can be primary key. Okay, so we have B is a primary key, and it is already super key because super key is a super class, then candidate key come, then primary key come. Means super key can be made candidate key, and candidate key can be made as a primary key. One more thing about this key, it is super key only. Candidate key is this, and it is candidate key just because it is considered as a primary key. So if B is a primary key, so what about this? It will be a alternative key. Alternative key. What is alternative key? The key which is candidate key, but it is not considered as a primary key. Means we have selected B as a primary key, so except primary key all other the candidate key is considered as a alternative key. Means what about the alternative key? Why we are calling this again and again alternative key? Because we can use like it is a like additional key we have. It is additional key we have, like except primary key. Okay, now what is the next what we have the next, what can we what how can we find the number of super key? Okay, we know already that the minimal set of attribute we can consider as a primary key. We have already learned. Okay, so how many, like for example, we can see one more. Okay, about the essential element. Like we have this kind of relation. Okay, and this functionality we have In the exam they will also give you like this, okay. And what I have said that in the left side attribute we will find the closure property. So for A attribute we will find the closure, for B also and for C also. So for A, how can we find A itself? Okay, A. Then what is in functional dependency? A tends to B. So A tends, we are finding the closure property for A. So A tends to B means B will also come. Okay. So A itself has done. A tends to B. A functionality has done. Okay, two things we have already done. Now we have this functionality also. So we can check we can check this attribute also. A closure property A itself included. Now for B, what we will include, we will use the B functionality. B tends to C. So B has included. Then we check B functionality. B tends to C. So C will also include it. Now B functionality not there. We have done this functionality, and any other functionality for B is not there. Now what we will do next? Check the C. So we have the C functionality, one functionality for the C. So what can we do? We will include this also. A. So A is already there, already here. Okay. So which which element is missing? Which attribute is missing? D is not coming. Okay. So what happened that we will not consider it as a candidate. Okay, we are not consider any candidate key or like any super key. We are not considering this because these have missing D attribute. Okay, so same story for the B. B itself will come. B tends to C will come. Then C tends to A. Okay, we are checking C. So C tends to A. Okay, so A is also come. Now for check A tends to B. So B already included. Okay, so not need to. But again D is missing. So it is also not candidate key. It is also not. And again this C for itself, then functionality C tends to A, so A included. Then for we'll check A functionality A tends to B, so B included. Again B check B tends to C, so C is already included. Again D missing. So these all three are not the like candidate key. Okay. So what can we do? What can we do if like what things is happening there? That if we have D element, so these all three will be cover, right? All three will be cover. All three can be make as a like a candidate key. If we will D here, so can I add D here? If I will add D here, so A, we have already covered A functionalities through these and like checking all attribute. If I have added D, so directly I can see that D itself will also come. If I have added D, so B itself B, then D itself D is also come. C tends to C itself C already here. So if I add D, so D. So what is happening? AD, BD, and CD. In these three key, what is happening? That D is a essential element. We cannot like we have not any functionality, any specific functionality here. Functional dependency is not there. So D is our essential element. We have to add we have to add with all the key with all the like left side this attribute to make the like candidate key and super key or primary key. Okay, if you find closure property for D, okay, so for the closure property we will use this plus sign. Okay, this plus. So what will happen? D itself. No any functionality for D. So D will not consider as a CK, not CK. Okay, it is not considered as a CK. And we have added D, so it is all the candidate key. Okay, so so single attribute element is not there to make a candidate key. Candidate key is what? Minimal, okay, minimal set of attribute. If I can consider as a D, it will not be considered as a candidate key because we have seen that it is not included all these attribute. So D will also not. ABC we have previously checked ABC, BCA, CAB. So D was not there. So we have added DDD. So it means what? AD, BD, and CD. It is considered as a like collection of two attribute keys will be considered as a minimal set of attribute key, and that's why we are saying that this is a candidate key. Okay. So what will be super key? It is three are considered as a candidate key. So super key will be what like three set of attribute will be considered as a super key, like collection of any of attribute, any of whatever you can check it. Okay, so this will be super key. Okay, it has a three attribute more than candidate key attribute. Okay. Can we take one more example? If, like for we have a relation ABCD and we have AB tends to CD and D tends to A. These two functional dependency. Okay. So what can we do? Left side closure property. Okay. Find it. AB plus. Okay. So AB itself as it is come. Now check functional dependency AB CD. Okay, AB tends to CD, CD has zero. Then C check, C has no any function. D check, D tends to A already included. Okay, so it is including all the attribute. Okay, it is our candidate key. Okay, now what we will check? For D we will check D. D itself come. D tends to a functional dependency. Okay, A is come. Now what is happening is there what is happening is there that if we will check any functional dependency here, no, it has no any functional dependency. Okay, so what can we do? There is no any like D is not including all the attribute. Okay, so it is not candidate key obviously. Okay, so like this. Now again, what can we what we are saying like about the super key, finding the super key. Okay, how many super keys in the relationship? So we have learned already candidate key. Like if I have a relation and I have three attribute a1 a2 a3 and I have a1 is a ck. Okay, a1 is a ck. So question will definitely come, how many SK? Okay, possible. So for finding the SK, we have a formula is there. 2 की power n minus 1. N is what? N is number of attribute. Number of attribute. Okay. So we have three attribute. 2 power 3 minus 1 means 2 power is 2 is equal to 4. Okay. So we have 4 super key. We have four super key. और सीके तो कैंडिडेट की मीन्स हमारे पास A1 है. ओके, सो कैन वी चेक कैन वी चेक कैंडिडेट की, सॉरी, कैन वी चेक सुपर की like A1, A2, A3. Now these are our three column. Okay, so can we make the combination A1 A2 combination? Then again A2 A3 combination. Then again A1 A3. Okay, so what will be here? That we have A1 is a candidate key. So what will be happen? That we will we will make the super key not like this. So how can we make like super key? If super key is we are making, so super key have to include candidate key also. Okay, super key have to include candidate key also. So if we are making three candidate key or four candidate, sorry, if we are making three super key or four super keys, so they will include the candidate key also. They will definitely include candidate key also. So like this, A1, A1 we have candidate key, then A1, A2, then A1, A3, then A1, A2 and A3. Like this, we have four super key. So what can we say about also this, that it is our super key. So 2 power n minus 1 is the formula. Now if we have like this kind of relation A1, A2, A3, okay, and a number of attribute are in relation, and we have candidate what? Candidate key A1, A2 and A3. We have composite type of candidate key. We have three attribute in candidate key. Now how many number of SK is there? Number of SK. How can we find? So now this formula will change. Previously we have n minus 1 because we have candidate key attribute is 1, but now candidate key attribute is 3. So we will write this here 2 power n minus, so like this. Now next is, if we have relation a1 a2 and n number of, now what is happen if we have candidate key a1 a2 a1 a3, okay, so this 2 is our candidate key. So we have two candidate key. Now what happened? 2 n minus 2, okay, plus 2 n minus 2. One for this one and second for this one. Now minus 2, then how many number of attribute is this? A1, A2, and A1 is also there, so we will not count again in A3. So number of attribute is 3. So this formula will work for us. Okay. Like if we have attribute here 4. So what will be our formula? This one. Okay. So like this we will find. Now we can consider one more question like A, B, C, D, E, F, G, H. This is our relation, and we have to find number of super key here. And functional dependency is CH tends to G, and A tends to BC. You have to find out that which element is missing, which attribute is missing here. Find out from the functional dependency. Which attribute is missing in this? Which is essential element is here? Tell me. CAG is functional dependency A, B, C, B, C, F, G. What is missing? I think D is missing is here. So essential elements will be become D because if D not any attribute is not in functional dependency, we have to include, if we have like finding the closure of A or closure of A, closure of any of the left side attributes or attribute we are finding. So it is not in functional dependency, so we will add this element and then we will find closure property. Okay. So for finding candidate key, for finding super key, we have to just find the closure property. Obviously, super key is a obviously super key is a super class. Then candidate key is a subset of any super key, and candidate key cannot be substitute, means it can we cannot make subset of candidate key. It is already minimal set of attribute, so we cannot make subset. Okay. And super key include candidate key. Okay. And the primary key will be candidate key. Okay. So like this will be happened. And obviously like in candidate to find the super key we have to include we have to include the candidate key in super key. Like in previous example, like this. So we have A1 is a candidate key. So we are finding the how many super keys. So it is saying like A1 is a candidate key. So I have said that candidate key is a subset of super key. What is the mean state? Means if A1 is a super key, sorry, candidate key. So in other super key, A1 will also include. Okay, then maybe then not maybe must be other elements will also added with this. So candidate key will be considered as a super key, right? That's why we have added A1 here. Then we will with the A1 we are adding other elements also. So like this we have four super key. Now I think you have clear all these things. If you have any doubts, so please comment. You can ask. And in the next video, we will definitely come with the new topic, with the new numericals, or with any PYQs questions related to this. Okay. Okay. Thank you.